But first, I just wanted to start with some example topologies. So if we think about retail, it's a pretty complicated, stack of communication that needs to occur. Previous life, I ran a medium to large size retail network, and this is something that we saw all the time, where your POS system has a few jobs, right? It both needs to facilitate the transaction and get the customer through the line, but it also needs to update inventory about what was sold. It needs to go out and maybe run a credit card payment, look up a customer account, all sorts of things, kind of multi, application endpoints that may need to be reached out. And again, the speed of those interactions is really going to be tied directly to your ability to conduct business. In the case of a POS system, that's where the transactions happen. And ultimately, if the computer is very slow, suddenly lines will back up and you risk kind of the attrition rate of people jumping out of line because this I don't have time for those type of situations. So it's a very real example of where application performance can impact business, but you can imagine, this is a POS system. The same things will hold up across really most verticals. If you think in healthcare, somebody meeting with a patient and it's taking forever to get their patient record to show up, that's similarly going to impact that experience. Medical billing, there's a certain amount of times they can spend with patients. They don't want to be spending it all waiting for the computer to pull up data for them. So lots of examples we can think of, but really cases where the actual latency of an application is going to directly impact business performance. So again, in a retail example, we'll have our little local network, our actual POS systems, maybe a store-specific inventory database so they can go back and forth, check, do I actually have this item to sell? Perfect, I do. Subtract one from the whole, the standing inventory, things like that. These are going to be places that are basically at the local access layer for the store. And again, like really the first step in our journey to where we can jump into the network, collect information, and really enumerate how the application's performing. So for just some general background, we are talking about NetFlow and IPFIX here. Typically, when you're talking about NetFlow and IPFIX, you have your key fields. What are the items in a flow that define that flow? You think of the 5-tuple most often: source IP, source port, destination IP, destination port, and protocol. Anytime you have that unique combination go through the device, it'll open an entry in the flow cache and start to collect information about it. The typical collection fields we think of are like packet delta counts, byte delta counts. Those are going to be the things that you use to really enumerate the just general usage of that conversation on the network. But today, what we're exploring are devices like our Flow Pro or Cisco devices that run AVC or many other probes that can actually calculate performance statistics while that entry is open in the flow cache. It exports those in IPFIX and NetFlow data, as we'd expect with everything else, and then ultimately collecting those metrics over a long period of time allow us to not only analyze how an application is performing instantaneously, but rewind time back to the point of an incident. Maybe we're triaging a ticket where a user felt some sort of performance degradation, reported it. It's not happening right now as the investigation begins in the knock, but by collecting these metrics over time, we can actually kind of rewind back to when it all occurred and take a look at the state of things when the actual incident was reported. So again, this is starting at the local access level within like a retail environment as example. These are going to be the first places that we could tap into the network, get an idea of how that POS system is actually communicating with its local infrastructure, and start to break down, is the network a delay? Is the application a delay? You'd imagine at an access layer, there's really not a lot of network to get in the way. So again, it helps us develop evidence to show that applications are slow to respond. As we kind of roll this topology out, there'll be enterprise level authorities. So anything that the local store database can't resolve for a POS system, maybe customer accounts, somebody wants to charge something to an account or use credit they have on an account or loyalty points or whatever type of schema is in place. It's going to be something that isn't the authority for that data isn't in the local store. Maybe you have 1,000 stores. It has to go up to a higher level in the network, maybe haul back to the headquarters, go out to a cloud application, check that information, and again, exposes us to another hop in the network where it may be beneficial to actually get some measurements out of how that's performing. Again, so we can tell, is there a WAN side issue here between the stores and the back end resources? Is it the application? Is it the network? Again, just another observation point that'll be interesting. And then finally, we have kind of the last hop, the cloud services backend. So if that means there's live sales, live pricing, maybe it's a dynamic. We have a a retail chain up here in Maine that is an old kind of record store situation where they will buy and sell things from people who come in. They have the ability on the back end of their system to actually reach out, query the internet, get a fair price for purchasing, used products back from people, and then in real time giving an offer that makes sense for their model. So in that case, right from the POS, you need to actually be able to get all the way out to cloud services that can give you that data. And again, exposing many more hops, maybe a hop between the store and the headquarters, and then headquarters in the cloud, or however they have that traffic shaped. But again, more hops in the network where it's going to be really important to get some latency metrics when we're trying to triage performance incidents later on. So if we think about just kind of an example flow, we'd have our first hop at the local level. We want to get an idea between client, server latency, the actual application latency. Same kind of situation when you actually go to look up that customer account. Now we're going beyond our local access layer. We need to move up into the network a bit. Are there further points that may be causing network side latency? Is there a new application that may be slow? Again, if you think of the POS reaching out to lots of little like microservices to resolve things between inventory, customer information, et cetera, the application delay may not be consistent across those. And this is another way that we can, by dropping these probes in, have some idea as to, the customer information service actually returns very quickly, but the inventory updates are what's slow. The network doesn't appear to be an issue here, but now we have an idea about what microservices are actually holding up the course of business. And then finally, any jump that's going to have to go out to another external resource, again, exposes another part of the network to us where there may be some sort of slowdown. And again, external applications that we may not even have a local team that's an authority to, but we use basically as a user. Is there delay in those services? Is there something we can escalate up to those cloud offerings that we're using to show, I can prove to you through the metrics I've collected in NetFlow and IPFIX that our client and server delays are actually quite responsive against this application, but anytime a query is made to it, we're being slowed down significantly. And here's actually some hard data that shows that's the case. So it immediately eliminates some of the back and forth that you'd run into in any of those triage scenarios. And then finally, for any kind of PCI vertical, if you have a separate segment, that's going to be really, really sensitive to performance. If you're a large retail environment, you're probably running thousands of credit card transactions a minute. And any slowdown in that or any queuing that ends up happening in that chain will really start to cause a very tangible performance impact that will, again, risk kind of the churn of people who are maybe waiting to check out that are low on time and they're trying to just move through. So again, lots of little connections that add up to a fairly large picture when viewed in the composite. And again, getting insight into all of these individual hops and where the latency can be attributed is going to be super helpful for breaking down any sort of impact that's around these kind of complex multi-hop, multi-service, multi-topology crossing application situations. So again, this is kind of the traditional retail stack where you have lots of layers to it. You're going through the enterprise and then again out to external resources when they're needed. And then more often than not, more on the SMB side of things, you may have entirely cloud-based retail services. So again, any type of issue in these environments, it's going to be more important than ever that you have hard evidence that you've collected and you can actually show that the application is where the delay lies and not any sort of kind of local network issue or queuing issue. So we'll take a look at how these metrics are broken down next. We'll kind of jump into the product and see what they look like, and then we can kind of talk about what that means for setting DSCP values and how things can be retuned in order to fix any sort of network side problem, and then ultimately how we can provide evidence around explicit application problems and kick those over to the teams that can hopefully re-index some table in the database or find ultimately what the slowdown is there.